All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. So, how is it going, guys? And if you have not liked the session, I would want you guys to smash the like button because this session is extremely important when it comes to the NEET 2025. Okay, we'll be talking about a rest of the topics which we were supposed to cover in the part 1. So that's why this is going to be the part 2. Okay. Yes, and let everybody join, let the people come, and we are starting this session, okay, accordingly. And make sure you smash the like button because liking the session means marking the attendance, and marking the attendance is extremely important, okay? And I will be starting from the scratch. I'll be starting from the scratch. Doesn't matter if you have studied this chapter before, okay? Whatever the topics I'll be starting from the basics so that you'd be able to understand each and every single thing. And it'll be to the point, okay? Will not waste time in derivations and all. So, how is it going? Guys, make sure you smash the like button. Everybody out there, hit the like button, hit the like button. Everyone means everyone. So, my dear NEET aspirants, we have only 40 days left when it comes to the NEET 2025, okay? And I hope you are aggressive at this point of time, okay? And when it comes to the end moment, there are only two things which matter. That is a revision plus we say mock test, okay? Revision plus mock test. So that's why we say at the end moment, you guys are supposed to revise all the things, whatever you have studied till now, Okay. Now, my dear NEET aspirants, let's dive into the today's session, okay? And the first topic, which is extremely important, okay? And the first topic, which is extremely important, that is acceleration due to gravity, okay? Every single year question comes from this particular topic. You can expect the question from this topic. What does acceleration due to gravity actually mean? I'll be showing you all the cases of the acceleration due to gravity as well as the problems, okay? My dear friends, listen. Let's suppose I say I have got a block over here. This is a block. And mass of the block is m. You have got a block, its mass is m. I'm saying, sir, if you are applying force on this block, let's suppose, force on this block. We say due to this force, acceleration will come. We say, sir, we have studied F is equal to mass into acceleration from Newton's second law. And from here, acceleration is equal to force upon mass, F divided by m. So basically, this is the acceleration which is due to this force. If I say acceleration is in this mass, which is due to what force? This is due to this F force. Okay. Now, similarly, let's suppose this is the Earth over here. Radius of Earth is R. Mass of Earth is M. ME is the mass of Earth. RE is the radius of Earth. And on the surface of Earth, you are placing an object. This is the object which you are placing on the surface of Earth. Okay. Now, my dear friends, I am asking you the simple question. Is there any force acting on this particular mass due to this Earth? We say yes. That's called gravitational force. Whenever two objects are placed near to each other, they apply gravitational force on each other. Now, here we say force on mass m. Can I say that force will be F is equal to G? We say capital M, small m divided by R square. G m1, m2 by R square. This is the force on this mass, okay, due to this Earth. Now, whenever force acts on a body, we say acceleration is developed. Acceleration is force divided by mass. So can I say in this particular case, acceleration will be force divided by mass? Yes. So can I say here this acceleration will come out to be force is how much? That is G capital M, small m divided by r square. And then you have this mass over here that is divided by m. This and this will cancel. So this will come out to be, that is gm divided by r square. Can I say, my dear friends, this is the acceleration which is due to this gravitational force. This is the acceleration which is due to this, I would say, force, which is due to this gravity. Okay. Can I say this is the acceleration which is due to this gravitational force, which is due to this gravity? Yes. So that's why we call this acceleration as acceleration due to gravity. I'll be sending you to notes, okay? The notes of the previous session also, the notes of this session also. Chill. Once we get done with this session. So this is the acceleration due to gravity. This is the acceleration due to this gravitational force, and we represent it with G naught. So basically G naught is equal to gm divided by r square. So this is the acceleration due to gravitational force. This is the acceleration due to gravitational force, or we can call it, this is the acceleration due to gravity. As simple as that, okay? This is the acceleration due to gravity. Now, my dear friends, this is the acceleration due to gravity, and mass is present exactly on the surface of Earth. So this is the acceleration due to gravity. This is the acceleration due to gravity on the surface of Earth, That is gm by r square, Yes, sir. Now, guys, I would want you guys to understand one thing. What is that? See. Let's suppose when it comes to the density, everybody knows that, sir, density means rho. Density is mass divided by volume. Everybody knows density is mass by volume. Guys, when I say density of Earth, you say, sir, that is mass of Earth. Okay, I say that is me. And volume of Earth, volume is sphere. It is sphere. Earth is spherical in shape. I can say then this is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume. Now from here, can you calculate mass of Earth? That will be 4 by 3. This 4 by 3. Then we say rho e. Then we say pi. Then we say re cube. Yes. So this is mass of Earth that we calculated. Now, my dear NEET aspirants, I want you guys to put this in the equation first, okay? Guys. This part only I am deriving over here so that I can take you from the basics, so that you get to understand everything, okay? Rest of the things, I will not derive over here. So give me just 2 minutes, okay? That's it. Now, put this in the equation first. Here. Instead of mass of Earth, I can say put in equation first. So can I say acceleration due to gravity on the surface of Earth? This will come out to be, that is g divided by r square. Okay. Then instead of mass, I will be writing 4 by 3 pi. Okay. Then rho e, then we say r cube. Okay. Now this r square and r cube will cancel. So this g naught will come out to be, that is 4 by 3. We say g rho pi, and then we say r. Now, my dear NEET aspirants, in this particular case, can I say this is also the acceleration due to gravity? In terms of density. This is also the acceleration due to gravity in terms of density. How many of you are clear with this? Please tell me in the chats. Please tell me in the chats. This is the formula of acceleration due to gravity in terms of density of Earth. Okay. And this is the formula of acceleration due to gravity in terms of mass of Earth. Now, guys, listen to me very carefully. If I say, see, G means universal gravitational constant. If I say mass is constant, guys, if mass is constant, G is already constant. In that particular case, G naught is inversely proportional to R square. Okay. Video is not clear. Is there any problem in the video? I think it's fine, huh? It's perfectly fine, guys. Okay, okay. Now guys, if mass is constant, we say in that case, G naught is inversely proportional to R square. Okay. If density is constant, 4 by 3 is already constant, G is constant, pi is constant, then G naught is directly proportional to radius. So can I say, my dear friends, if somebody asks you the graph between G naught versus RE, always remember, if they say density is constant, I'll show you the questions also, then G naught is proportional to RE and graph will be straight line. And if, my dear friends, mass is given as constant in the question, then G naught versus RE will be the rectangular hyperbola. Okay, so G naught is inversely proportional to R square. So it completely depends upon what is given in the question. If mass is constant, this will be the graph. Okay, if mass is constant, this will be the graph. If density is constant, this will be the graph. As simple as that. As simple as that. Let's take a look at the question. Okay. Let's take a look at the question. Okay, see, two planets having same density. You have got the two planets, okay, which has the same density, means density is given as constant. Okay, the acceleration due to gravity would be, guys, tell me one thing. When I say acceleration due to gravity, can I not say, sir, that is 4 by 3 pi G rho and then we say R? So if density is given as constant, G is constant, pi is constant, 4 by 3 pi is constant, 4 by 3 is constant. So I can say G is proportional to R, radius. So the one which has got bigger radius, the one which is the bigger planet, will be having more acceleration due to gravity. So which option is correct? So greater on the larger planet. So can I say the acceleration due to gravity would be greater on the larger planet? Option C. Why? Because density is given as constant. Let's take a look at this question. A planet having same density and same acceleration due to gravity as that of Earth. You have got a planet over here. You have got Earth over here. This is Earth, this is planet. Okay, this is planet and this is Earth. It says that a planet having same density and same acceleration due to gravity as that of Earth, we say G is same, okay, and acceleration due to gravity, small g is same, and density is also same. Okay, and universal gravitational constant G is twice at that of Earth, means universal gravitational constant, capital G, of this planet is 2 times universal gravitational constant of Earth, The ratio of the radii will be, you guys are supposed to find ratio of the planet, radius of planet divided by radius of Earth. This ratio you guys are supposed to find out. Guys, in this particular case, I say density is given. Which formula I am supposed to use over here? So I am saying in this particular case, we say acceleration due to gravity, that is 4 by 3, then pi, we say G rho, and then we say R. I'll use this particular formula. Why? Because in the question, density is given. So obviously I'll be using this formula. Now guys, tell me, G is constant. We say density is same for both. 4 by 3 is constant. Pi is constant. Okay, this rho is constant. So I can say this G and R, I can say this G multiplied by R is constant. Okay, so can I not say this radius will be inversely proportional to universal gravitational constant? Yes, I can say it something like that. Now, my dear friends, if I say radius of planet divided by radius of Earth, what will we say? Radius of planet. You'll be saying radius of planet, that is 1 by gravitational constant. So gravitational constant of planet is 2 times. So I would say this is 1 by 2 times GE upon, here I will write 1 divided by GE, 1 divided by GE. So can I say this radius of planet divided by radius of Earth, it will come out to be 1 by 2 times GE multiplied by GE divided by 1. If we take over there, this and this will cancel, so it will come out to be 1:2. It will come out to be 1:2. So this is the ratio, and this is the previous year question. Is this clear? Is this clear? Guys, we consider universal gravitational constant as constant everywhere. But in the question, they are saying assume, assume, assume. If the question says assume universal gravitational constant is twice as that of Earth, then we are assuming. That's it. We know the formula, we are applying the logic. That's it. Is that clear? Please tell me in the chats. Is this clear? Everyone means everyone. Is this clear? Tell me, guys. Is this clear? And smash the like button. Everybody mark the attendance. Smash the like button. That's great. Now, guys, previously I told you that is acceleration due to gravity on the surface of Earth. Let's suppose you are taking an object from the surface of Earth till height h. You have placed the mass over here. Okay. In this particular case, what will be the acceleration due to gravity? Guys, directly, I'll not derive now. Directly remember, previously it was G naught was, that is Gm divided by R square. Okay. Right now, what is the distance between this mass and this center? Re plus h. So here you will be writing Re plus h whole square. So Gh is equal to Gm divided by Re plus h whole square. Re plus h whole square. Okay. Now in terms of G naught, this is the acceleration due to gravity at height h. Now in terms of G naught, guys, we say we say G naught is equal to acceleration due to gravity on the surface of Earth. This is Gm divided by R square. Okay. Now take it over here. So this will be G naught into R square is equal to Gm. Okay. Now. Guys, I want you guys to put instead of this Gm, put this. Okay. So we'll be writing Gh in that particular case. It will be instead of this Gm, this will be G naught into R square upon. Here in the denominator, you will be writing Re plus h whole square. Okay. That is what is given over here. So this is basically acceleration due to gravity. This is basically acceleration due to gravity above the surface of Earth at height h. This is in terms of G naught. This is in terms of mass, in terms of acceleration due to gravity on the surface of Earth, in terms of mass. Okay. I'll provide you the notes of the first session also. Please wait. After this session, I'll send you the both. Next. Now, guys, let's suppose if height is much less than radius of Earth. Guys, how much is the radius of Earth? We say radius of Earth is that is 6,400 kilometers. Okay. Let's suppose if you take an object, guys, what is the acceleration due to gravity on the surface of Earth? 9.8 meter per second square. If you take the object up to 10 meters, 20 meters, 100 meters, sir, what will be the acceleration due to gravity? In that case, acceleration due to gravity does not change. It remains the same. If you take it at very large height, then it will change. That's what it is mentioned over here. If height is much less than radius of Earth, much less than means, let's suppose if you have 1 kilometer, compare 1 kilometer with 6,400 kilometer. 1 kilometer is very small when you compare it with the 6,400 kilometer. So that's why we say height here. If you take an object up to 1 kilometer, height is much less than radius of Earth. Even up to 10 kilometers, we assume height is much less than radius of Earth. up to 10 kilometers, we say acceleration due to gravity remains the same. Whatever is on the surface of Earth, same will be at that height. Please keep this in your mind. If height is much less than radius of Earth, then in that case, acceleration due to gravity remains the same. Next, if height is much less than radius of Earth, first case is much less than. This is height is much less than radius of Earth. Like if height is 16 kilometers, if you take an object at 16 kilometer height, if you take an object 32 kilometer height, if you take an object 64 kilometer height, 128 kilometer height, in that case, acceleration due to gravity changes. So this will be the acceleration due to gravity in that case. G naught, acceleration due to gravity on the surface of Earth, 1 minus 2h divided by r. H is that height, r is the radius of Earth. Please keep this in your mind. So this is valid only when height is between 10 kilometer to 500 kilometer. If height is less than 10 kilometer, then we assume whatever is the acceleration due to gravity on surface, same is going to be on that particular height. Okay. Now guys, one more important topic. What is that? That is percentage change in G. That is percentage change in G. See. If I'm saying you have an object, okay? You have an object. You have placed this object on the surface of Earth, okay? Now, if you are taking this object till height h, okay? We know acceleration due to gravity will change. Here it is g naught, here it is gh, it will change. How much is the percentage change in G? Sir, 5% acceleration due to gravity has changed. Sir, 10% has changed. 15% has changed. How do we calculate that? How do we exactly calculate that? How do we calculate that? Okay, that is what we call the percentage change in G at smaller height. If you take an object till height h, how much percent G will change? 5%, 10%. How do we calculate? Delta G divided by G multiplied by 100. This is change in G upon G, original value of G, multiplied by 100. This is what we call the percentage change in G. Percentage change in G. I'll show you the questions also, don't worry. This will be equals to minus 2h by r into 100. I'll show you the questions. This will give you the proper feel. This is how do we calculate the percentage change in G. This is how do we calculate the percentage change in G. Now guys, let me show you directly the question on this so that you would be able to understand this. Take a look. At what height above the surface of Earth, G decreases by 2%? If you take an object from the surface of Earth till height h, okay, it says that you take an object from the surface of Earth, till height h. This height is given as h. And G decreases by, we say 2%. At this point, G has decreased by how much? 2%. What will be the value of this height? You have to tell me what will be the value of this height. Guys, what is the formula that we use? Sir, that is percentage change in G. So that is delta G divided by G. This is change in G upon original value of G multiplied by 100. This is called percentage change in G. And this is given as 2%. Is equal to minus 2h divided by r into 100. Multiply with 100, it will give you a percentage. Now guys, tell me, value of this is given, value of this percentage change in G is given as 2% and it is decreased. So I would say minus 2% over here because it says acceleration due to gravity is decreased. That's why minus 2% will be equals to minus 2h divided by r. R is radius of Earth, that is 6400 kilometer. Multiplied by, we say 100. This 0000, 2, okay? Directly write it is 2%, so it is already in percent, so minus 2. 2, negative. So take it over here. So height will come out to be 6400 kilometers. So if you take an object at what height? 64 kilometers. Then acceleration due to gravity will decrease by 2%. Is this clear? Please tell me in the chats. Is this clear? I would want you guys to tell me in the chats. Is this clear? And smash the like button if you have not liked the session yet. Smash the like button if you have not liked the session yet. Is this clear? Everyone means everyone. That's great. That's great. Now, guys, a body weight 144 Newton on the surface of Earth. You have got, this is the surface of Earth, okay? A body is present on the surface of Earth. A body is present on the surface of Earth. Its weight is 144 Newton. Weight means m into g. If there is an object placed, its mass is m. Downward, we say mg. This is force. This is what we call weight. Weight means m into g. Now, what is the weight of this object at this particular point? We say W is equal to m into g naught. Mass of this object multiplied by acceleration due to gravity on the surface of Earth, because it is placed at surface of Earth. Okay. And its value is given as 144 Newton. It is given as 144 Newton. Then further it says, if it is taken to the height h, if we take this object to the height h, if we take this object to the height h, okay, if we take this object to the height h, h is equal to 3r, 3r. And what is r? R is the radius of Earth. R is the radius of Earth. It says that it would weigh, what will be its weight W dash over here? What will be its weight over here? Sir, it is simple. Weight is simply mass multiplied by acceleration due to gravity. Can I write W dash is going to be m, mass of object, and acceleration due to gravity at this point, that is going to be gh, because it is present at height h. Now tell me, what is the acceleration due to gravity at height h? That is g naught into r square upon re plus h whole square. I can write it like this. So you will be writing over here, in this particular case, W dash is equal to m. Then we say g naught into r square upon, then we say r plus h whole square. You guys can write it like this. Yes. Now tell me one thing. Can I write it W dash? It is going to be W dash. It is going to be. So mg. Okay. Do one thing. We can write it like this. M into g naught into r square upon. Guys. R square plus h square. Height is given as 3r. So 3r plus r is 4r. 4r whole square. That will be 16r square. Now this r square will cancel. M into g naught. Value of m into g naught is 144 Newton. So this is 144 divided by 16. That is going to be 9. So what is the weight of this particular object at height h is equal to 3r? That is 9 Newton. So means if you are a fat person, okay, your weight on the surface is large. It is not your problem. You go at a very large height, your weight will decrease. Here it is 144 Newton. At h is equal to 3r, you are only weighing how much? I would say that is 9 Newton. Is that clear? Boys and girls, let me know in the chats. Everyone means everyone. Everyone means everyone. Now, similarly, you have one more case for this one. That is acceleration due to gravity below the surface of Earth. We already discussed above the surface of Earth, on the surface, now below the surface of Earth. Now, in this particular case, if you take an object from the surface till depth d, this is the depth d, or from the center you go at what distance? At small r distance. Okay, from the center it is small r, from the surface it is at depth d. Whatever you say, I have no problem. Radius of Earth is re. In this particular case, acceleration due to gravity at distance r from the center, it is going to be gm into small r. Small r is the distance, okay, divided by r cube. Capital R is the radius of Earth. Now, my dear friends, in this particular case, what is this small r? See. This whole distance is capital R. Capital R minus d will be equals to small r. So this is small r. Now put it over here. Instead of small r, put it over here. You can write it something like this also. Capital R minus d. Okay. divided by r cube divided by r cube. Okay. Now, in terms of g naught also you can write it. Directly remember these expressions. Acceleration due to gravity at depth d. In terms of g naught, it is going to be g naught into 1 minus d divided by r. What is d? D is the depth, r is the radius of earth, g naught is the acceleration due to gravity on the surface. That's it. Now guys, if somebody says percentage change in g, if you go at some depth, how much g will change? How many percent g is going to change? That is, percentage change in g will be minus d by r into 100, minus d by r into 100. Here percentage change in g has different formula, and in this particular case percentage change in g has different formula, minus 2h by r into 100. Here it is different, and here it is different, here it is different. Okay. Now my dear NEET aspirants, let's take a look at the question. If the radius of earth shrinks by 1.5%, the value of acceleration due to gravity changes by. See guys. There is a simple formula. There is a simple method that we see in units and dimensions. See, let's suppose if you have a quantity, physical quantity, y is equal to x. Please take a look over here. I'll clear your basics. Notes of part 1 I'll be sharing once I get done with this particular session, okay? I'll share that. For this session also, this session notes as well as the notes of the previous session, I'll send both. Please now don't ask me in the chats. Now take a look. If you have a physical quantity, y is equal to x, okay? I can say y is that physical quantity which depends upon x. If x changes, y changes. If x changes, y changes. Yes. Now, my dear friends, I can say in this particular case, sir, if y is equal to x, if x changes, how do you write change in x? Delta x divided by x. Okay, this is how we write fractional value of x. Okay, fractional change in x. Sure, it will be delta y divided by y. Okay, yes. Now guys, if you have a physical quantity y is equal to x raised power n, if x changes over here, y also changes. How do you find change in y? You will be finding, sir, delta y divided by y. This is called the fractional change in y. Will be equal to, if you have power, take this power down, n down, delta x divided by x. Always remember this. Yes. Let's suppose if you have y is equal to x square. So delta y by y, 2 delta x by x. Okay. Let's suppose if you have y is equal to 1 by x square. So you'll be writing it something like this. Y is equal to x raised power minus 2. Now, if x changes, so I can write delta y divided by y will be equals to minus 2 delta x divided by x. Minus 2 basically says that x was in the denominator. Okay. Now, if you want to find this, its percentage change, so multiply with 100, multiply with 100. So this is the basic rule to find the percentage change. Now take a look. If the radius of Earth shrinks by 1.5%, guys, see, we say what is the acceleration due to gravity on the surface of Earth? That is gm divided by r square. It says that if you have Earth, if its radius is shrinking, decreasing, what will happen to g naught? See. We say g is constant, m is constant. Can I say g naught is equal to 1 by r square? It is inversely proportional to r square. If r changes, g will change. You'll be write it like this, guys. Delta g divided by g will be equals to. Here in this particular case, you'll be writing minus 2 delta r divided by r. Minus 2 delta r divided by r. Okay. And if you want to find in the percent, you'll be writing delta g divided by g multiplied by 100 is equal to minus 2 delta r divided by r into 100. This is called the percentage change. This is how we exactly find the percentage change of any formula. Now guys, take a look. If the radius of Earth shrinks by 1.5%, delta r by r into 100, this is percentage change in radius. So this is given as 1.5%. So I can say in this particular case, delta G divided by G, that multiplied by 100. This is percentage change in G will be minus 2 into, what is the value of this? What is the value of this? This is 1.5. 1.5%, okay, 1.5%. Okay, and I would say minus 1.5. Why? Because radius of Earth is shrinking, decreasing. That's why. So minus 2 into minus 1.5. So this is going to be 3%. So percentage change in G will come out to be how much? That is going to be 3%. Is this clear? Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Everyone means everyone. Tell me, guys. Is this clear? Guys, smash the like button. If you have not liked the session yet, I would want you guys to smash the like button and mark your attendance. Okay. Now, let's move on to the next question. Let's move on to the next question. Let's move on to the next question. This is the next question that we have exactly on the screen. If the density of the planet is double that of the Earth and radius is 1.5 times, you have got a planet and you have got the Earth. This is Earth. This is the planet. Okay, this is Earth. This is planet. It says that density of the planet is double than that of Earth. The density of this planet is 2 times the density of Earth. Okay, and radius of this planet is given as 1.5 times the radius of Earth. Okay, the acceleration due to gravity on the surface of the planet will be, the acceleration due to gravity on the surface of the planet is, guys, when it comes to the acceleration due to gravity, that is 4 by 3 pi g rho, and we say r. This is acceleration due to gravity in terms of density, because density is given over here. Now you tell me one thing, when it comes to the acceleration due to gravity in this particular case, what is constant? Guys, tell me, acceleration due to gravity of the planet, it is going to be 4 by 3 pi, okay, and g as it is, okay. Now density is given as 2 times of rho e, okay. Density of planet is 2 times of rho e, and radius of planet is given as 1.5, means 3 divided by 2 radius of Earth. Yes, okay. If you consider this as for Earth, okay, for Earth, so here Earth, here Earth. Now 2 and 2 will cancel, so you'll be writing 3 times 4 by 3 pi g rho and r. Now what is this? This is acceleration due to gravity on the surface. So on the Earth, so we say acceleration due to gravity of the planet is 3 times acceleration due to gravity on Earth. Okay. Okay. Next, let's take a look at this. At what depth below the surface of Earth, the G, value of G is same as that of the height of 5 kilometers. See, guys. When it comes to this particular question, see. At what depth below the surface of Earth, the value of G is same as that of the height 5 kilometers. See? Let's suppose this is Earth over here. Okay. Now from the surface of Earth at height, we say h is equal to 5 kilometers. Value of acceleration due to gravity is g dash. Now it says that at what depth, value of acceleration due to gravity is same, that is g dash. You are supposed to find if h is equal, at h is equal to 5 kilometers, value of acceleration due to gravity is something. What is the value of acceleration due to gravity at what depth? The acceleration due to gravity will be same. Guys, tell me one thing. What is the value of acceleration due to gravity here? That is g naught. Now, here it is g dash. What will be the percentage? What will be the percentage change in g? Sir, the percentage change in g from here to here will be same as percentage change in g from here to here. As simple, bro. If it is 10, this is also 10. So now, let's suppose this is 5. So how much will be change? Sir, 10 minus 5. Here also 10 minus 5. So this change will be same. Change will be same. Now tell me. When it comes to percentage change in g at height h, how do you write that? Sir, delta g divided by g into 100. At height h, you write it minus 2h divided by r. When it comes to the percentage change in g at depth, you will be saying, sir, delta g divided by g into 100 is equal to minus d divided by r. Don't you think here percentage change will be exactly here? This percentage change is same. This percentage change is same. So if these two are same, so can I not say from first and second, I would say minus 2h divided by r will be equals to minus d divided by r. Now minus and minus goes, r and r goes, so d will come out to be 2 into h. So that will be 2 into 5. H is given as 5, so that will be 10 kilometers. Is this clear? Simple logic you are applying over here. Whatever is the change in g at height h, same will be the change in g at that depth. Then you are balancing the equation and getting the answer. Is this question clear to each and every single student? Is this question clear to each and every single student? Okay. This question. The moon's radius is 1 by 4 times. The moon's radius is 1 by 4 times that of the earth. You are given over here a moon. This is moon. Okay. You are given over here earth. Okay. It says that the radius of moon, okay, the radius of moon, Rm, it is given as 1 by 4 times that of earth. That is Re divided by 4. 1 by 4 times radius of earth. And mass of moon, it is given as 1 by 80 times mass of earth. So mass of earth divided by 80. Mass of earth divided by 80. Okay. Then further it says, if g represents the acceleration due to gravity on the surface of earth, then the acceleration due to gravity on the surface of moon will be. Guys. Acceleration due to gravity on the surface of earth is gm by r square. Okay, this is Re when it comes to earth. When it comes to moon, how do we write it? Sir, this is acceleration due to gravity on moon. That is g into mass of moon divided by radius of moon. Yes. Now tell me, sir, and it's square. Sir, g acceleration due to gravity on moon. Then this will be g. Mass of moon, that is me by 80. Mass of earth divided by 80. Okay. Then radius of moon, that is re square by 4. So that is re square divided by 4 square is 16. 16 ones are 5 is r. Okay. Now this will come out to be 1 by 5 gme divided by re square. So don't you think that acceleration due to gravity on the moon will be now this acceleration due to gravity on the surface g naught divided by 5. Is this clear? Is this clear? Guys, give me the signal in the chats and smash the like button. Everyone means everyone. Liking the session is mandatory. Is that clear? Is that clear, guys? Is that clear, guys? I would want you guys to tell me. Is this crystalline clear so that we can move on to the next topic? So that we can move on to the next topic. Everyone means everyone. Okay, one more important thing over here, graph between acceleration due to gravity versus small r, okay? In this particular case, directly remember when it comes to the graph between acceleration due to gravity and small r, okay? Now, this is the center of Earth. From the center of Earth till the surface, it is going to be straight line. It will be directly proportional. And then from the surface to outside, it will be inversely proportional. Okay, it will be inversely proportional. Logic I have mentioned in this particular case. Inside, acceleration due to gravity is equal to this. So G is directly proportional to this. And when it comes to outside, guys, what is the acceleration due to gravity above the surface of Earth? G naught into RE square upon R plus H whole square. This R plus H you can consider as small r. So now G is inversely proportional to small r square, inversely. Okay, okay. And from center to surface is directly. This graph is very important. This graph is very important. Okay, they might directly ask you this particular graph. They might directly ask you this particular graph. Now, guys, let's move on to the next topic. That is the most important topic. That is what we call YDSE, Young's double slit experiment. Acceleration due to gravity, its cases and problems I'm done with. Now, let's move on to the YDSE, Young's double slit experiment. Before moving on to the Young's double slit experiment, you guys should understand what does path difference mean, what does phase difference mean. Okay, take a look. I'll make you understand. Let's suppose you have a wave which starts from point A. This wave starts from point A. Okay. You have another wave which starts from point B. This is another wave which starts from point B. Okay. Yes. Now, this wave has traveled 5 kilometers. This wave has traveled 10 kilometers. Okay. 5 kilometers and 10 kilometers. Now, my dear friends, in this particular case, when it comes to the path difference, I say, sir, how much is the difference in their path? This has traveled less, this has traveled more. So that is 10 minus 5, that is 5. Simple. Now, what is phase difference? See, guys, if you have the two waves, this blue color wave and this yellow color wave. Now, in this particular case, when yellow color wave starts from 0, minimum, blue color also starts from 0. When yellow becomes maximum at this time, yellow becomes maximum. Even blue also becomes maximum at the same time. We say the two waves have got 0 phase difference. Phi is 0 here. The two waves are in phase. When two waves become maximum at the same time, minimum at the same time, means two waves are in phase. Phase difference is 0. Okay. Like here. Take a look. This wave, when it starts from 0, this already starts from maximum. When this becomes maximum, this becomes 0. So here, phase difference in this case is pi divided by 2. Phase difference in this case is pi divided by 2. Okay. Now here, when this starts from 0 and becomes maximum from the upper side, this becomes maximum from the lower side. Here, phase difference is 180 degrees. In this case, these two waves have phase difference 180 degrees. They have 90 degrees. And this has got 0 phase difference. This has got 0 phase difference. Okay. Now guys, take a look. There is a topic that is what we call constructive interference and destructive interference. Constructive and destructive interference. See, let's suppose you have got a wave over here. This wave is traveling something like this. Okay. You have got another wave over here. This wave is coming from that side. Now, when crust of two waves meet, when crust, this is called crust. Guys, see. This is called crust, this is called trough. Crust, trough. When crust of two waves meet, if crust of two waves meet, we say the amplitude becomes large. In that case, amplitude becomes large. This is the resulting amplitude. If this has A, resulting amplitude will be 2A. And this is what we call constructive interference. This is what we call constructive interference. So constructive interference means when crust of two waves meet, and in that case, we say amplitude becomes maximum. In that case, we say amplitude becomes maximum. When crust of two waves meet, amplitude becomes maximum. Okay. And it is called constructive interference. It is called constructive interference. Okay. And in this case, it has got the zero phase difference. It has got the zero phase difference. Okay. Okay. So in case of constructive interference, how much is the phase difference? Zero. Okay. And what happens to the amplitude? Amplitude becomes large. That is 2A. Okay. Okay. Like this wave and this wave, they have got zero phase difference. Okay. So here it is constructive interference. Here resultant amplitude will increase. Okay. Yes. Now, what is destructive interference? If crust of one wave and trough of another wave meets, in that case, we say amplitude becomes zero. See, this has got zero amplitude. And this is what we call destructive interference. When crust and trough meets, it is called destructive interference. In this case, amplitude is zero. In this case, amplitude is zero. Okay. 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 And my dear friends, when we say what is the phase difference in case of destructive interference, so we say phi is equal to 180 degrees, or you say pi, So from now onwards, when crust of two waves meet, constructive interference, amplitude will increase. It will become 2A. Okay, if the A and A is having the amplitude of two waves. Okay, and in case of destructive, we say amplitude becomes zero. Now guys, see. Let's suppose, understand this very carefully. If you have two waves, this is the equation of first wave. Y1 is equal to A1 sine omega t. And what is this A1? A1 means amplitude of a wave. A, how high it can go. Okay, amplitude of the wave. Sine omega t. Another wave has got A2 sine omega t. This is the amplitude of another wave. Now, these two amplitudes we can show with a vector something like this. This is A1 and here you see A2 sine omega t plus phi. What is the difference between these two? Sir, this is only sine omega t. This is sine omega t plus phi. So difference between the two here is phi. Difference between the two is phi. This is A1, this is A2. If you have got the amplitude of two waves, and if they ask you to find the net amplitude, always remember net amplitude will be, that is A net square, A1 square plus A2 square plus twice A1 A2 cos phi, like you find the resultant of two vectors. Similarly in this particular case. Now, if the angle between the two waves is 180 degrees, you will be putting cos 180 over here. Then you can find the resultant amplitude. This is how you can find the resultant amplitude of two waves. Now guys, what I want you to understand in this particular case, see, when it comes to the constructive interference, you say, what is the value of phi? That is 0. What is the value of cos phi? That is 1. And if you want to find the resultant amplitude, how can you find the resultant amplitude? That is A net square. That is going to be A1. So that is A1 square. That is A square plus A square. Okay, A1 square plus A2 square plus 2 times of A1, A2. Then we say cos of 0. Cos of 0, that is cos 1. Now, this will come out to be A net square. This will come out to be, that is 2A square plus cos 0 is 1 plus 2A square in this particular case. Okay. Now, my dear friends, cos 0 is 1, 2A square plus 2A square. That is 4A square. So, I can say in this particular case, A net will come out to be square. That is 4A square. Okay. Now, take this root over here. In this case, A net will come out to be, that is root 4A square. That will come out to be 2A. That will come out to be 2A. Okay. That's what I was explaining. When phi is 0, cos phi is 1. In case of constructive interference, net amplitude is, we can say 2A. Sir, what if the two waves do not have the same amplitude? Then you can say A1, A2, twice A1, A2 cos of phi. Okay. And when you have cos this, in this particular case, A net is going to be 0. Net amplitude will be 0. You can use the same formula, that is A net square is equal to A1 square plus A2 square plus 2 times A1 A2 cos of 180. You can use this formula and you'll get the net amplitude 0. Now, important point in this one is intensity. See, important point in this one is intensity. Okay, see guys, when it comes to the intensity, intensity means power divided by area, energy upon time. Forget about this. Intensity is directly proportional to amplitude square. Intensity is directly proportional to amplitude square. Okay, okay, okay. Intensity is directly proportional to amplitude square. So wherever you see A square, replace it with I. Replace it with I. Now come here. Guys. Replace it with I. Now tell me. If you have this equation, A net square is equal to A1 square plus A2 square plus 2 times A1 A2 cos of phi. Now you have to write the intensity formula like if you have a wave, it has got intensity I1. If you have another wave, it has got intensity I2. Sir, what will be the resultant intensity of the two waves? How can we find? See, instead of A net square, I will be writing I net. Because replace A square with I. Here it is going to be I1 plus I2 plus 2 times of A1. Guys, we say A square is equal to I. Replace A square with I. Can I say A will be equals to root of I if you take the square over here? Now instead of A, I will be writing root of I1, root of I2, then we say cos of phi. This will be the formula in that particular case. This is the formula for resultant intensity. This is the formula for resultant intensity. Now take a look. Guys. I want you to understand this. For constructive interference, if you have a wave, if you have another wave, if they are meeting and constructive interference is taking place, so in that particular case, we say, what is the value of phi? That is 0. What is the value of cos phi? That is 1. When cos phi is 1, what will be the resultant intensity in that case when two waves meet constructively? I net is equal to I1, I2 twice root of I1 cos phi. Cos phi is 1. Okay. Now guys, this you can write it something like this. Root I1 plus I2 whole square, because it is A plus B whole square. If you open this up, it will come out to be this only. Always remember, this is what we call the maximum intensity. Because when two waves meet constructively, constructive interference takes place. So intensity is maximum in that case. Now, if I1 is equal to I2, then we can say this will be 2 times of root I naught. Okay. Then this square and this will cancel. Okay. And 2 square is 4. It will become 4 times of I naught. So this is the maximum intensity. Okay. And this, if the two waves have got the same intensity, this will be the net intensity in that case. Now, for destructive interference, okay, what is the value of phi? That is 180 degree. What is the value of cos phi? That is -1. Okay. Okay. Now, if you find the resultant intensity I1, I2, then we say minus 2 times of root I1, root I2. Why? Because cos here is -1. You can write this as A minus B whole square. This is called minimum intensity. And if I1 is equal to I2, then this will become 0. Resultant intensity will become 0. So in case of destructive interference, resultant intensity is 0. In case of constructive interference, resultant intensity is 4 times of I. This is the general formula and this is the general formula. Okay. If somebody asks you, what is the I max divided by I minimum, you'll be saying this one. You'll be saying this one. Please tell me in the chats, is the concept of intensity clear? Is the concept of intensity clear? Tell me. Is the concept of intensity clear? Tell me, guys. I would want you guys to give me the signal in the chats. Is this clear? And guys, smash the like button and mark your attendance. Everybody out there. Smash the like button, guys. Make sure you hit the like button. Now, guys, let's move on to this part. Let's see where constructive interference takes place. Guys, when it comes to the constructive interference, what is the value of phi? You say, sir, that is 0 degrees. Okay. Okay. So, sir, is this only 0 degrees where constructive interference takes place, or there are some other values also? We say general formula is phi is equal to 2n pi. Okay. So these are the values. This is the general formula. If you put n is equal to 0, so this term will become 0. So at n is equal to 0, phi will be 0. If you put n is equal to 1, it will be 2 pi, 360. Okay. If you put n is equal to 2, this will be 4 pi. Okay. If you put n is equal to 3, this will be 6 pi. So at all these values of phi, constructive interference takes place. Similarly, when it comes to the destructive interference, sir, what is the general formula for destructive interference? 2n minus 1 into pi. If n is equal to 1, 2 into 1 is 2, 2 minus 1 is 1. So it will be pi. So phi, value of phi is pi. Okay. 2 into 2 is 4, 4 minus 1 is 3. So it will be 3 pi. So it is 3 pi, 5 pi, 7 pi. So at all these values of phi, of phase difference, destructive interference takes place. Okay, destructive interference takes place. Now guys, so constructive interference takes place at 0, 2 pi, 4 pi. Destructive interference takes place at we say pi, 3 pi, 5 pi, 7 pi, and so on. One more important formula. Path difference in case of constructive and destructive interference. For constructive interference, guys, if two waves are meeting, constructive interference is taking place. And if somebody says, what is the path difference? Path difference is n times of lambda. Lambda is the wavelength. Okay. Now, if n is equal to 0, path difference will be 0. If n is equal to 1, path difference will be lambda. If n is equal to 2, path difference will be 2 lambda. So at all these values, constructive interference takes place. So when two waves meet and constructive interference takes place, path difference can be 0, lambda, 2 lambda, 3 lambda. Okay. Similarly, when it comes to the destructive interference, in case of destructive interference, path difference is 2n minus 1 into lambda by 2. If n is equal to 1, put n 1 over here, 2 minus 1 is 1. So path difference will be lambda by 2. If n is equal to 2, path difference will be 3 lambda by 2. Then 5 lambda by 2. So at these path differences, we said destructive interference will take place. So I have told you constructive and destructive interference over here. Let's move on to some questions, and then I will we say 60% of Young's double slit experiment is done. Now, two beams of light having the intensities I and 4I. You have got a light which has intensity I. You have got another beam which has got intensity 4I. Okay. Interfere to produce a fringe pattern on the screen. Okay. The phase difference between the two beams is pi by 2 at point A. Let's suppose if the two beams are meeting, and here at point A, phase difference comes out to be pi by 2. This is point A. Okay. Yes. Then it says if the same two waves are meeting at point B, if the two waves are meeting at point B, phase difference is coming out to be, that is 2 pi. This is I, this is 4I. Then it says find out the difference between the resultant intensities. See guys, if I ask you what is the resultant intensity in this case, I can say IA. That is going to be I1, I2, that is going to be I plus 4I plus 2 times of root I, root 4I, okay? Then we say cos of pi by 2, cos 90. Now this cos 90 is 0, this term will become 0, 4I plus I is 5I. So resultant intensity at A is 5I. Resultant intensity at A is 5I. Similarly, if we talk about the resultant intensity at B, you'll be saying, sir, at this point B will be I plus 4I, okay? Then we say plus 2 times of root I under root of 4I, okay? Root I under root of 4I, okay? Then we say cos of 2 pi, 360. Now in this case, if you calculate it, it will come out to be 9I. So this is the resultant intensity at A. This is the resultant intensity at B. Now difference in their resultant intensity is, that is IB minus IA. That is going to be 9I minus 5I. That will come out to be 4. 4I is the correct answer. 4I is the correct answer. This is a similar question. Okay. Two coherent sources emitting the light of intensity I naught interfere in a medium at point where phase difference is 2 pi by 3. The resultant intensity will be, guys, when it comes to the net resultant intensity, how do you find? I naught plus I naught, I1, I2 plus 2 times of under root I naught, then we say cos of 2 pi divided by 3, because phase difference is 2 pi by 3. Solve it and get the answer. Two sinusoidal waves, intensity I and same frequency, okay, and same amplitude, interferes constructively. The resultant intensity at the point I, 4I. Already discussed, na? Resultant intensity will be 4I. Yes. I can say in this particular, how do you find it? How do you find it, guys? I net is going to be when the two waves interfere constructively. In that particular case, how do you find the constructive interference? How do you find the resultant intensity? Okay, maximum. Root of I1 plus root of I2 whole square, and this comes out to be 4 times of I0. Root of I1 plus root of I2 whole square. I would say root of I1 plus a root of I2 whole square. Now here it says that two waves have got the same intensity. So root of I plus root of I whole square. So 2 times root of I, so it will come out to be 4I. Young's double slit experiment, okay? 80% of the Young's double slit experiment is already done. Constructive, destructive, we are done with that. Okay? Okay? Now guys, take a look, take a look. When it comes to the Young's double slit experiment, understand this very carefully. Understand this very carefully. Understand this very carefully. Young's double slit experiment means you have got a thin hole, okay? Or you take a light source over here. This is a light source. From the light source, light is coming out. This is the light coming out of the light source. Then you take a small slits over here. You take a small slits over here. Then light is passing through these slits, okay? Light is passing through these slits. Now, my dear friends, when light passes through these slits, we place a screen over here. On the screen, we observe that a fringe patterns are made. Fringe patterns are made, okay? Okay. So this is what we call maxima. Maxima. Or you call bright fringe. A kind of pattern is made on the screen, bright, dark, bright, dark, bright, dark, bright, dark, something like that. Okay. And this one also, this is called first maxima. This is called first maxima. Okay. And this is called second maxima, and so on. And this is what we call minima. This is the first minima. Okay. This is what we call second minima. This is what we call second minima. Okay. And my dear friends, this is maxima and this is called central maxima. Okay, which is exactly at the center. So Young's double slit experiment says that when a light passes through the two narrow slits, then it falls on the screen. A bright dark pattern is made on the screen. This bright fringe, dark fringe, bright fringe, dark fringe. Okay. These bright fringes are called maximas, dark fringes are called minimas. Okay, this central maxima, this is what we call the central bright, and this is what we call the first minima. This is second minima. Okay, okay, yes. Now, my dear friends, what does it actually happen? We say this maxima is formed. When two waves meet over here constructively. So minimas are formed when two waves meet constructively. Sorry, maximas are formed when two waves meet constructively. Minimas are formed when two waves meet destructively. So that's why we say here constructive interference takes place, destructive interference takes place. Constructive, destructive, constructive, destructive. Okay. Okay. Now, in this particular case, guys, if we talk about the central maxima, what is going to be the part difference? Guys, I have told you previously, when it comes to the constructive interference, okay, in case of constructive interference, what is going to be the part difference? Part difference can be 0, lambda, 2 lambda, 3 lambda, 4 lambda. When it comes to the destructive interference, part difference is lambda by 2, 3 lambda by 2, 5 lambda by 2. So if we talk about this maxima and minima, so for maxima, constructive interference takes place. So part difference is lambda. For first minima, part difference is lambda by 2. For first maxima, part difference is lambda. For first second minima, part difference is 3 lambda by 2, and so on and so on. So this is the part difference in case of maximas and minimas. Okay, yes. Okay. Now we know that in case of delta x is 0, lambda, 2 lambda, 3 lambda, maximas are formed. General formula is this. This also we have studied previously. Okay. Now guys, what is important in this particular case? Distance at which the maxima and minimas are formed. Distance at which the maximas and minimas are formed. Guys, see. This is the central maxima at this point. Okay. Let's suppose at this particular point, a fringe is formed. It can be maxima or minima. Okay. It can be maxima or minima. A fringe is formed. Sir, how much is this distance? At what distance this fringe is formed? This is y is equal to delta x d by d. What is this capital D? Capital D is the distance between the slits and the screen. What is small d? Small d is the distance between the two slits, S1 and S2. Okay. Now, if we talk about a question, over here, see what does the question say? Question says, find the distance of fifth minima from the central maxima. Guys, y is equal to delta x d divided by d. Delta x d divided by d. Okay. If we talk about the fifth minima, guys, for fifth minima, what is going to be the part difference when it comes to the minima? Guys, part difference for minima, 2n minus 1 lambda by 2. 2n minus 1 lambda by 2. I can write this will be, that is 2n minus 1 lambda divided by 2. Now tell me, if it is talking about the fifth minima, for fifth minima, what is the value of n? N will be 5. Okay. Now put it over here. Delta x will come out to be 2 into 5 is 10. 10 minus 1 is 9. So this will be 9 lambda by 2. So distance of this fifth minima, it will come out to be y is equal to, instead of delta x, it is going to be 9 lambda by 2. Okay. 9 lambda d divided by small d. This is the answer. Then guys, take a look here. Take a look. Find the distance of seventh maxima from the central maxima. Find the distance of seventh maxima from the central maxima. Find the distance of seventh maxima from the central maxima. Seventh maxima. Guys, how do you find del y is equal to delta x? We say d divided by d. Delta x d divided by d. And for maxima, what is going to be the value of this? This will be n times of lambda. And for 7, it will be 7 lambda. So can I not say y will come out to be 7 lambda d divided by d? So this is the position of the maxima or minima from the central maxima. Okay, at what distance it is formed. So when it comes to the Young's double slit experiment, only constructive and destructive interference is the concept. Constructive interference is where maximas are formed. Destructive interference is where minimas are formed. And I have told you the formula for path difference. I have told you formula for phase difference in case of constructive and destructive. Okay. 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 Now guys. Fringe width. Let's suppose this is the fringe that is being made over here. This is the fringe that is made. What is the width? How wider the fringe is? This is the bright fringe. How wider the fringe is? That is beta lambda d by d. Lambda d by d, this will be the fringe width. Simply, like. Then you have angular fringe width. Guys, if this is the fringe over here, okay? Now, if you join this with one end, and this is the topmost end, angularly, how much is this angle? That is called the angular fringe width. And always remember, this is equal to lambda divided by d. Lambda divided by d. This is the angular fringe width. Okay. Now, if you take a look over here, in this particular case, in Young's double slit experiment, if the separation between the slits is halved, okay, and distance between the slits is, and the screen is doubled, the fringe width compared to the original will be beta is equal to lambda d divided by d. This is the formula. Lambda d divided by d. It says that if the separation between the slits is halved, separation between the slits means small d. So d dash becomes d by 2. Okay, d dash becomes d by 2. Okay. Separation between the slits is halved. And distance between the slit and the screen is doubled. So d dash becomes 2d. 2 capital D. The fringe width will be, what is going to be the new fringe width? Beta is equal to lambda. Instead of this, I will be writing 2d. Instead of this, I'll be writing d by 2. 2 into 2 is 4. Beta will come out to be 4 times lambda d divided by d. So beta will be 4 times this original beta. So fringe width will increase by 4 times. What about this? In a Young's double slit experiment, blue light of wavelength 500 nanometer. So wavelength is given as 500 nanometer. When you convert nanometer to meters, multiply with 10 raised power minus 9. Okay, it will be meters. Okay, yes. The slits are 1.20 mm apart. So means D is given as 1.2 into 10 raised power minus 3 meters. The viewing screen is 5.4 meter away. So capital D is given as 5.4. The fringe width will be, so fringe width beta is equal to lambda D divided by D. Now lambda is given as 500 into 10 raised power minus 9. Okay, D is given as 1.2 in D is given as 5.4. This is given as 1.2 into 10 raised power minus 3. Okay, check out what is the answer. I guess option first. Okay, then you have non-standard YDSE. Then you have non-standard YDSE. Guys, what is non-standard YDSE? Non-standard YDSE means when you do this Young's double slit experiment in a medium. Previously, you were doing this in air. Now you are placing this in a medium where refractive index of that medium is mu. In this particular case, always remember, wavelength in this medium will be lambda divided by mu. Wavelength in air divided by refractive index of that medium. See. In this particular case, I would want you guys to directly remember, this is position of the maxima at what position, at what distance y will be formed. Okay, maxima will be formed. That is going to be n lambda d divided by mu times of d. Like in this case, what was the position of maxima? In this case, position of maximum was delta x d divided by d. And when it comes to the maxima, position of maxima, it is going to be n lambda d divided by d. When it comes to the minima, it is going to be 2n minus 1 lambda divided by 2 d divided by d. Because part difference for minima is this one. So in this particular case, when it comes to the non-standard YDSE, here, this is going to be the position of maxima. This is going to be the position of minima. What you are supposed to do, instead of lambda, you are supposed to put lambda divided by mu. Instead of lambda, you are supposed to put lambda divided by mu. That's it. Okay. And when it comes to the fringe width, fringe width will be, previously it was lambda d by d, right now it will be lambda divided by mu d divided by d. Instead of lambda medium, you have to replace it with lambda divided by mu. That's it. Is this clear? Is this clear? Please tell me in the chats. And smash the like button if you have not liked the session yet. Is this clear? So, in case of non-standard YDSE, you have to use the same formula, n lambda d by d. But instead of lambda medium, you will be putting lambda by mu. That's it. Instead of lambda medium, you will be putting lambda by mu. That's it. Rest everything is same. Okay. And we are done with this. Let's move on to the next most important topic, that is Gauss law. Before this, give me the signal in the chats. Even in, I would say, guys, the topic that I have explained over here, we say 70% wave optics I have covered. Wave optics chapter. 70% wave optics chapter I have covered in this one. Even 80% I would say. Now only there is one topic left in wave optics, that is diffraction. Okay. YDSE is the main, and intensity, constructive, destructive, I have covered all of those. Amplitude. Okay, guys, give me the signal in the chats, then only I'm moving forward. Okay. Tell me quickly in the chats, is this clear? That's great. Any Kashmiri in the chats? Tell me. Any Kashmiri student in the chats? Okay. Now guys, take a look. Now guys, take a look. Gauss law. What does Gauss law actually say? Gauss law says that it says that flux through any closed surface is equal to the charge inside divided by epsilon naught. See guys, let's suppose I'll make a sphere over here. Let's suppose I'll make a sphere over here. This is the sphere that I'm making. Okay, this is the sphere. This is the sphere that I have. Okay. And my dear friends, inside this sphere, I'll place a charge. This is the charge which is placed inside the sphere. Everybody knows that, sir, whenever you have a charge, electric field comes out of the charge, okay? It produces the electric field around it. And we show that electric field with the help of these electric field lines. Okay? Now guys, whenever electric field lines cross any surface, we say flux is produced. Sir, if the electric field lines cross this board, flux is produced through the board? Yes. Whenever electric field lines cross through any surface, we say flux is produced. Here, these field lines are crossing this particular surface. So field is produced. So flux is produced. Now, if I say, what is the amount of flux produced through this closed surface? This is a closed surface, okay? Gauss said, you don't have to calculate it. You simply say, sir, how much is the charge inside? Divide by epsilon naught. That will be the flux through the surface. Sir, if I say, I have got a cylinder over here. Inside the cylinder, if I place 10 Q charge, how much will be the flux through the surface? Sir, simply flux through this closed surface. Condition is surface must be closed. We say flux will be charge inside enclosed, that is 10Q divided by epsilon. Okay, yes. Now, let's suppose here, sir, if the charge is placed inside, what is the flux through this closed surface cylinder? Q by epsilon naught. Here inside the cube, it is Q by epsilon naught. Okay. Let's suppose if the charge is placed somewhere around over here at the corner. This charge is right now not enclosed. It is not present inside. It is not enclosed. So what we do in this particular case is, see guys, what we do in this particular case is, if you have a cylinder something like this, okay, you place a charge over here. What we do is, we attach an imaginary cylinder to it. Now, this is what we call the closed surface. Okay. Now, in this particular case, when it comes to the flux through closed surface, that will be flux through two cylinders. Why? Because here, for this charge, closed surface is made of two cylinders. Okay. Why? Because for this charge will behave like an enclosed charge when you attach one more cylinder from this side. So this will be equals to Q divided by epsilon naught. Now tell me, through two cylinders, this much is the flux. Through one cylinder, how much will be the flux? Half of this one. So flux through one cylinder, it will be, that is 1 by 2, half of Q by epsilon naught. That will be Q divided by 2 epsilon. Okay. That will be Q divided by 2 epsilon naught. Now, in this case, let's suppose you have got this figure. In this case, you have a charge placed at the edge. Here, the charge is not placed inside. In this particular case, if you want to make this charge as enclosed charge, how many cubes you need to attach? One from this side, this side, this side. Total of 3 more. Now tell me, here, flux through the closed surface will be flux through 4 cubes. Because when you attach 3 more cubes to it, then this will come at the center. This will be Q divided by epsilon naught. So this is the flux through 4 cubes. Flux through 1 cube will be how much? That will be 1 by 4 of Q divided by epsilon. Okay. What about this one? This is placed at the corner. This place at the corner. This place at the corner. How many more cubes you need to attach over here? Then this will come at the center. Sir, 7 more cubes. Here, flux through closed surface will be flux through 8 cubes total. Flux through 8 cubes in total. And that will be equals to Q divided by epsilon naught. Now, this is the flux through 8 cubes. How much will be the flux through 1 cube? So flux through 1 cube in this case will be 1 by 8 of Q divided by epsilon naught. 1 by 8 of Q divided by epsilon naught. What about this? Flux passing through this curved surface, okay, is phi. Find the flux passing through Q. Okay. See guys, when it comes to a cylinder, if we take a cylinder, let's suppose this is the cylinder. This cylinder has got 3 surfaces in total. First one is this curved one. Second is this. Third is this. 2 plane surfaces, 1 curved surface. 2 plane surfaces, 1 curved surface. Okay. Now guys, can I say in this particular case, flux through this closed surface? This closed surface is made of 3 surfaces, 2 plane, 1 curved. That will be flux through 2 plane surfaces plus flux through 1 curved surface. Now, charge is placed inside. Net flux through this closed surface will be Q divided by epsilon naught is equal to flux through 2 plane surfaces. Sir, flux through 2 plane surfaces plus flux through curved surface, that is R, that is given as phi. Now take it over here. Flux through 2 plane surfaces will be Q divided by epsilon naught minus this phi. Now, this is the flux through 2 surfaces, two plane surfaces. Flux through 1 plane surface will be how much? Flux through 1 plane surface will be how much? Half of this, 1 by 2, Q divided by epsilon naught minus phi. This is the answer. What about this one? Find the flux through the curved surface. Find the flux through the curved part. Okay. Find the flux through the curved part. Let's do one thing in this particular case. If I give you, it's something like this. Find the flux through the curved part. If flux through plane surface is phi naught. If flux through plane surface is phi naught. Now guys, in this particular case, I can say when it comes to this closed surface, here this closed surface, it is made up of curved surface plus plane surface. So this will be flux through plane surface plus flux through curved surface. Now flux through this closed surface will be Q divided by epsilon naught is equal to flux through plane surface. What is the flux through this plane surface? That is given as phi plus flux through curved surface. Now take it over here. Flux through this will be Q divided by epsilon naught minus phi. Okay, this one. Find the flux through the sphere. This is a rod. It has got the linear charge density of lambda. Okay. Tell me the answer of this question. Tell me, guys. Guys, if you want to find the flux through this sphere, then you have to first calculate the charge inside the sphere. See guys. First and the foremost thing, guys, see. When it comes to the charge inside, we say lambda is equal to Q total charge divided by total length. Q divided by L, dQ by dL. Okay. Now Q will be equals to lambda into L. Q will be equals to lambda into L. So lambda is given. You are supposed to find what is the length of this part from here to here. How much length is placed inside. Multiply here, you will get the charge. Now see, this is R by 2. This is R. What is going to be this length? This is also R, radius. This is R by 2, this is R. And this part, it will be X. Okay. Now, can I say hypotenuse square, R square, will be equals to base square. That is R square divided by 4 plus, because R by 2 whole square is R square by 4 plus X square. Now, take it over here. This will be R square minus R square by 4 plus is equal to X square. Okay. Now, 4R square minus R square, 3R square by 4. 3R square divided by 4 is equal to X square. Further, you can write X will be equals to a root 3R divided by 2. Now, guys, if you got this X, if this is X, this will be also X. What is the total length present inside? That is 2X. So, 2X is going to be, that is 2 times of root 3R divided by 2. This and this will cancel. So, this will be root 3R. This will be L. So, this is the length present inside. Now, if you got the length, how much will be the charge? Charge will be lambda into L. That is a root 3R. This is the charge inside. Now, if you got the charge present inside the sphere, how can you find the flux? Sir, flux is going to be charge inside divided by epsilon naught. That is a root 3R lambda divided by epsilon naught. This is the answer to the question. This is the answer to the question. Okay. And what about this one, guys? What about this one? What about this one? This is the previous year JEE mains question. This is a charge placed inside at L by 2 distance. This is the charge placed outside at L by 2 distance. Now see, the number of electric field lines coming out of this, that is passing through this side, okay, passing through this side, will be same as the number of field lines, will be same as the number of field lines passing through this, will be number of same. So the flux coming out of this charge passing through this side, okay, so this is outward flux and here this is inward flux. So net flux through this particular side ABCD, that is going to be 0. Phi net will come out to be 0 through this side. So when it comes to the side ABCD, how much is the net flux? That is 0. Why? Because the number of field lines coming in is equal to the number of field lines going out. That's why we say flux through this portion ABCD. It is going to be 0. Okay. Now, let's move on to the next one. Galvanometer, ammeter. Conversion of galvanometer into ammeter. Let's talk about this topic now. Tell me, is this clear? Is this clear? Guys, smash the like button if you have not liked this session and do it quickly. Okay. Now you have got galvanometer. You have got galvanometer. Understand very carefully. What is a galvanometer? We say galvanometer is a device which is used to detect the current, okay, and which measures the small range of currents also. It is that device which detects the current, which measures the small range of currents also. Sir, what if we send large currents through it? It is going to burn the galvanometer. If the large current flows through the galvanometer, it will burn it. That's why it only measures small range of currents. Okay. Even it measures the voltage also. Okay. Okay. Now. But it has a problem. It has a problem. It has a problem. I say it produces large error. First problem is it measures the small range of currents. It cannot measure the large current. Second problem is it produces large error. So what do we do in order to overcome that problem? And how do we make the galvanometer? See guys, galvanometer looks something like this. This is the galvanometer, okay? And what is this G? G means the resistance of galvanometer. The resistance of galvanometer. Galvanometer has its own resistance. And we say, let's suppose IG is the current flowing in the galvanometer. I'll write over here, IG, it is the maximum current flowing in galvanometer. IG is the maximum current that can flow in the galvanometer. Okay, yes. Now guys, take a look. What I want you to understand in this particular case, that is conversion of galvanometer into an ammeter. Sir, since you said galvanometer is that device which measures the small range of currents, which produce the large errors. Sir, please tell me, how can we overcome this problem? We'll do one thing. We'll convert this galvanometer into a new device that is called ammeter. Ammeter is also a galvanometer, but the better version of galvanometer, which will produce very less error, which will measure the large range of currents. Now see, this is the galvanometer that you have. How do you make it the ammeter? Connect a resistance to it in parallel. Okay, this resistance in parallel. Now this resistance is called shunt resistance. Okay, when you connect the shunt resistance parallel to the galvanometer, we say this will behave like an ammeter. This becomes an ammeter. Okay, now see, let's suppose if you send the large current, okay, sir, through the galvanometer only IG will flow. This is the maximum current. Okay, only IG will flow. Rest of the current, this is I minus IG will flow through this shunt. Okay, I minus IG will flow through this shunt. And if somebody says, what is the value of this shunt? Always remember, value of this shunt will be IG into G. IG is the current in galvanometer. G is the resistance of galvanometer. Divided by I minus IG. This is the shunt. Let's take a look at the question. A galvanometer of resistance 100 ohms, value of G is given as 100 ohms, is used to measure 10 ampere current. Value of current is 10 ampere. Find the value of shunt resistance. You guys are supposed to value of shunt. If connected in parallel, so that its range becomes 50 ampere. Okay, IG is given as 10, I is given as 50 ampere. So means galvanometer should be able to measure 50 ampere. Okay, and how much is the maximum current it can flow? That is 10. How do you find shunt? Shunt is going to be IG into G upon I minus IG. Now IG into G, IG is 10, G is 100, I minus IG, that is 50 minus 10, that is 40. This and this will cancel. 100 minus 40, that is 25 ohms. So you guys are supposed to apply 25 ohms. You guys are supposed to apply 25 ohms resistance in parallel. Then it can measure the current of 50 amperes. Is this clear? Is this clear? Let's take a look at this question. In an ammeter, 0.2% of main current passes through the galvanometer. You have got an ammeter. Okay, this is the ammeter. 0.2% of main current flows through the galvanometer. 0.2 I. How much is the rest? I minus, this is 100%. 100 minus 0.2, that will be 99.8. 99.8 will flow through the shunt. Okay. If the resistance of the galvanometer is G, then resistance of ammeter would be, it is not asking us to find the shunt. It is asking us to find the net resistance of the ammeter. In order to find the net resistance of the ammeter, first you guys are supposed to find out the shunt. When you get the value of shunt, when you get this shunt, then you can find the resistance of galvanometer. See guys, first let's find shunt. Shunt is Ig into G upon I minus Ig. Okay. Ig into G upon I minus Ig. So I would say shunt is Ig into G upon I minus Ig. Now tell me, how much is the value of Ig? That is 0.2 I. Okay. G is G upon I minus Ig, 99.8 I. 99.8 I. I and I will cancel. So shunt will come out to be 0.2, that is 2 divided by 10. This is G multiplied by 998 divided by 10. Okay. 10 and 10 will go 2 and this is 499. So this is G divided by 499. So shunt comes out to be G divided by 499. Okay. Now if shunt comes out to be G divided by 499, let's find the resistance of ammeter. Sir, resistance of ammeter will be this resistance, you know, this you know. How do we find the resistances when the two resistors are in parallel? Sir, R1, R2 upon R1 plus R2. This is how we find the equivalent resistance and parallel combination. Now, R1 is this resistance, R2 is this resistance. That is G into G divided by 499 upon G plus G divided by 499. Okay. Now this will become G square divided by 499 upon 400G plus G is 500G. 500G divided by 499. Now this square G. So answer is G by 500. So what is the resistance of ammeter? That is G divided by 500, resistance of the ammeter. Now see, take a look at this question. A, B, C are given as 3 voltmeters. Okay, this is the voltmeter, this is the voltmeter. First, let's understand voltmeter. Now take a look. Conversion of galvanometer into the voltmeter. Conversion of galvanometer into a voltmeter. We say voltmeter is a device which measures potential difference. Or we say voltage. When you connect the shunt resistance in parallel, it becomes ammeter. When you connect the shunt resistance in series, it becomes voltmeter. When you connect shunt resistance in series, it becomes voltmeter. When you connect shunt resistance in parallel, okay, see, when you connect shunt resistance in series, it becomes voltmeter. Okay, when you connect shunt resistance in parallel, it becomes ammeter. Now, here in this particular case, shunt resistance in series. So this is now called as voltmeter. Now, how much is the value of shunt in this particular case? V divided by Ig. V is the voltage of the entire galvanometer divided by Ig. Ig is the current in the galvanometer minus G. G is the resistance of the galvanometer. This is how we find. Now, let me show you the question. A galvanometer has a resistance of 100 ohms. G is given as 100 ohms. Gives a full scale deflection of 30 milliampere. current Ig in this case will flow, that is 30 milliampere. That is 30 into 10 raised power minus 3 ampere. If it is to work as a voltmeter, now if we convert this galvanometer into a voltmeter, okay, we connect shunt resistance in parallel, and voltage of that voltmeter is 30 volts. You guys are supposed to find the value of shunt resistance. It says that you have got a galvanometer, its resistance is given, current in the galvanometer is given. You connect the shunt resistance in series, it becomes the voltmeter. And voltage is given. Find the value of the shunt. Guys, how do we find the shunt? S is equal to VG, V divided by IG, okay, minus S, minus G, minus G, minus G. Now, S will be equals to V, that is 30 divided by IG, 13 10 raised power minus 3 minus 100. Now this and this will cancel. This goes in the numerator. 10 raised power plus 3, that is 1000 minus 100. So it will come out to be 900 ohms. So the value of shunt resistance in this particular case must be how much? 900 ohms. Is this clear? Is this clear? Tell me, guys. Now take a look. A, B, C are the 3 voltmeters. A, B, C are the 3 voltmeters, are the voltmeters of resistance R. This has got resistance R. This has got resistance 1.5 R. This has got resistance 3 R. Okay. When a potential difference is applied across X and Y, when a potential difference is applied across X and Y, okay, the readings of the voltmeter are VA, VB, and VC. It says that the readings of all the 3 voltmeters are VA and VB, VC. Okay, then you have to find the relation between VA and VB, VC. See guys. Always remember, let's suppose if you have a resistance over here, one more resistance over here, and let's suppose this is a 10 volt battery. If I say, let's suppose this is 5 ohms, this is 5 ohms, okay? Sir, both the resistances are same. This potential difference will divide over here. So it will go 5 here, 5 here. Oh, it is same. It is same. Okay, yes. Now guys, listen to me very carefully. Listen to me very carefully. This is 1.5 R, this is 3 R. Could you please tell me what is the combination of these two? Equivalent of these two? Sir, R equivalent in this particular case, that is R1, R2. 1.5 means 3 divided by 2. 3 by 2R into 3R upon 3 by 2R plus 3R. Okay? Okay. Now, if you solve this, it will come out to be equal to R. Okay? So means equivalent of these is R. Now make this. Now instead of this, I'll make a resistance. This. Instead of these two, I'll make resistance. This is R, this is R. Now this is a potential difference applied. Now whatever the potential difference this battery will give to this, okay, let's suppose X. What about this one? Here also it will be X. Okay. Because when the resistors are same, it will be X. So if the potential difference across this is X, potential difference across this will be also how much? X. Now, this and this is parallel. So across this also it will be X, across this also it will be X. So can I say potential difference across A, this reading will be equal to this reading, will be equal to this reading? This is the answer. This is the previous year question. VA is equal to VB is equal to VC. Okay. Okay. So basically what I'm trying to say in this particular case is, we say a resultant of this one and this one is also R. So whatever is the potential difference across this, same will be across this and this. So that's why reading of all the three is same. Okay. Now is the concept of meter bridge. Now is the concept of meter bridge. Okay. Now let's move on to the concept of meter bridge. What does meter bridge actually say? What does meter bridge actually say? We say it's an instrument used to measure the unknown resistance. It's an instrument used to measure the unknown resistance. It's based on the concept of Wheatstone bridge. See guys, simply, I'll tell you to remember one equation when it comes to this. I'll tell you to remember one equation when it. Just a second, guys. See guys. See, when it comes to the meter bridge, you will be given a known resistance over here. Known means its value you know. You'll be given an unknown resistance over here. Okay, yes. And there is a jockey, and this is the wire, meter wire, 100 centimeters long. Okay. Now see, you will have to slide this jockey over here in such a way so that you find the balance point. Balance point means when current through this wire becomes zero. Current through this wire becomes zero. Okay. Now guys, when current through this wire becomes zero, take this portion of the wire, this portion of the wire. Okay. This has got some resistance. Okay. This has got some resistance. Okay. And this has also got some resistance. Let's suppose this is X and this is Y. Now, Wheatstone bridge concept you might have heard. Wheatstone bridge concept you might have heard. What does Wheatstone bridge concept say? Sir, this is one resistance, another resistance, another resistance, another resistance, and this is the fifth resistance. Wheatstone bridge concept says that if this resistance P divided by this resistance Q will be equals to R divided by S, then current through this resistance becomes zero. So means you can remove this. So if current through this is zero, then P divided by Q will be equals to R divided by S. This is the concept of Wheatstone bridge. Now, same concept in case of meter bridge. If you find the balance point means that point when current through this wire is zero. When current through this wire is zero, this resistance by this resistance will be equal to this resistance by this resistance. That's it. Now, what is the equation and what is the work of meter bridge? To find the unknown resistance. This is known, you have to find this. Let me show you the question. Like this. See guys. This is a meter bridge over here. Okay, let's take a look at this one. This is a meter bridge over here. Okay. Guys, understand very carefully. When it comes to the equation of meter bridge, see. We say this portion. Understand this very carefully. If I am saying, sir, this has got length L and it has got resistance R. This has got length L and resistance has got R. And my dear friends, from here to here, this length is L1. You are getting the balance length L1. Could you please tell me one concept I define? We say lambda is equal to R divided by L, resistance per unit length. Lambda means total resistance by total length. So basically, L length has got R resistance. Now, can I say here, in this particular case, R will be equals to lambda into L. This is the formula. Now, could you please tell me what is going to be the resistance of this portion? You'll be saying, sir, that will be, sir, resistance of this will be lambda into L1 because lambda into length, lambda into L1. Similarly, what will be the resistance of this? Lambda into its length. That is 100 minus L1. Because if this is L, total is 100. This will be 100 minus L1. Okay. Guys, what I'm trying to say when it comes to the meter bridge, you have got this wire. This entire wire has got resistance R. Length is L. Now, what is the resistance on its unit length? That is R divided by L. Now, here, resistance will be lambda into L. Now, how can you find the resistance of this portion? Lambda into L1. Resistance of this portion, lambda into 100 minus L1. Now, don't you think this will look like a Wheatstone bridge? PQ, lambda into L1, lambda into 100 minus L1. Current through the middle portion is 0. So, can I say this divided by this by this, will be equal to this divided by this? Yes, P divided by this. Now, lambda will cancel. So, final equation will be this, where L1 is the balancing length. So, balancing length is that length at which current through this middle wire becomes 0. At which current through the middle wire becomes 0. Let's take a look at the question. Here in this question, balancing length is given as 20. You are supposed to find the value of X. Guys, what can we say? This divided by this. Use the formula. P divided by L1. P is how much? 5 divided by L1, 20, will be equals to Q divided by 100 minus L1. That is X divided by 100 minus L1. 100 minus 20, that is 80. 2 ones are 2 4s are 5 4s are. X will come out to be 20 ohms. So with the help of meter bridge, we are able to find unknown resistance. Simple. Now one more. Let's take a look at this. In the following circuit, a meter bridge is shown in its balanced state. The meter bridge has the resistance 1 ohm per centimeter. 1 ohm per centimeter. Okay. And 1 ohm centimeter. Okay. R into L. Okay. Ohm cent, not per centimeter, ohm centimeter. Okay. Calculate the value of unknown resistance X. Okay. This X. Current drawn by the battery, okay, of negligible internal resistance. Let me show you. First, let's find the value of this X. Guys. Balancing length is at 40 centimeter. If this is 40, how much is the 60? Can I say this divided by this? X divided by balancing length is 40. P divided by L1 will be equals to this Q, 6 divided by, how much is this? This is 60. 100 minus 40, that is 60. This and this will cancel. Okay, 6 will cancel. So X will come out to be 4 ohms. Okay, X will come out to be 4 ohms. Now guys, understand one thing very carefully. You got the value of this. You have to find the current in the entire circuit. Find the current drawn by the battery, means current in the circuit. In order to find the current in the circuit, you have to find the net equivalent resistance of this. Now this X is how much? We say 4. I see. What is given? 1 ohm per centimeter. Resistance, we can say 1 ohm centimeter is given. Means per centimeter. If you take 1 centimeter over here, it has got how much resistance? 1 ohm. 40 centimeters will have how much resistance? 40 ohms. 1 centimeter has got 1 ohm. 40 centimeters will have how much resistance? 40 centimeters. This will have 60 ohm. 60 centimeters, 60 ohm. 40 centimeter, 40 ohm. Now, this and this. See, I'll make the resultant. This and this in series. 6 plus 4 is 10. So this will be 10. Now, this and this, 6 plus 60 plus 40 is 100. Now, this is 100 and the battery is connected like this. Now, 100 and 10, they are in parallel. Now, tell me, how do you find the R equivalent over here? That is going to be 100 into 10 divided by 100 plus 10. Okay. So, this will be 110, 110, this and this will go. So, 100 divided by 11 ohms is the net resistance. Now, this battery is 6 volt. Now, tell me, how do we find the current? Current is V divided by R. V is how much? That is 6. R is how much? 100 divided by 11. So, that will be 66 divided by 100. 0.66 ampere is the answer. Is this clear? Please tell me in the chats. Is this clear? Is this clear? Everyone means everyone. I would want you guys to tell me in the chats. ये क्लास मकलाव तो पढ़ने वास. Okay, so I hope you got the feel of meter bridge also. It helps us to find the unknown resistance. It works on the principle of Wheatstone bridge. Okay. Now guys, take a look. Take a look. Series LCR circuit. Series LCR circuit. Series LCR circuit. When it comes to the series LCR circuit, what does series LCR circuit actually mean? Guys, listen to me very carefully. You have got L. L means an inductor. L means an inductor. Okay. C means capacitor. R means resistor. Okay. When all these three are connected in series in a particular circuit, it is called series LCR circuit. And here you have connected an AC source. Here you have connected an AC source. Okay. AC source, like you have DC source. Sir, what is DC source? You say, I have a battery of 20 volts. What is this? This is DC source. Okay. Which gives direct current, unidirectional current. When it comes to the AC source, it has a voltage something like this. This is the voltage of an AC source. V0 sine omega t. It gives the alternating current, bidirectional current. Okay. And this is called series LCR circuit. Now, my dear friends, when it comes to the series LCR circuit, I want you to understand one thing. Okay. When it comes to the series LCR circuit, since this is the battery, alternating battery, which is connected to this, this and this. Let's suppose potential difference given to this is VL. Potential difference given to this is VC. Potential difference given to this is VR. VL, VC, VR. Okay. Yes. Now, my dear friends, always remember. When I say current, current here is I. Current here is I in this particular circuit. If I make its phasor diagram means representing this potential diff VR, VL and VC with in terms of vectors. Okay, these phasors, okay, vectors, straight. Always remember, current in an LCR circuit, this current in an LCR circuit, okay, this current in an LCR circuit, okay, this current and voltage, they are in the same phase. Voltage and current in case of an LCR circuit, they are in the same phase. Okay, voltage in case of resistance, and current are in the same phase. Same phase actually means something like this. See. If I say, sir, if we make a phasor diagram looks something like this. Sir, on this axis we write sine omega t, like this is positive x-axis. On this axis we write minus sine omega t. On this axis we write cos omega t. On this we write minus cos omega t. Now, if you have the voltage given over here, V0 sine omega t, so I will be making it on positive x-axis. If let's suppose it was minus V0 cos omega t, I would have made it on this axis from the negative side. If it was positive cos omega t, I would have made it from the upper side. This is how we make the phasor diagram. This is called the phasor diagram. Similarly, when I say in the phasor diagram, VR and current, they are in the same phase, so we make it in the forward direction. Okay, and when it comes to VC, guys, this topic is difficult to understand for that student whose basics of alternating current is not clear. I am sorry, but when it comes to understanding the phasor diagram in phase, basics of alternating current, you must clear that, okay? And I have covered that in my one-shot game of NEET marathon, okay? You can watch that, okay? But this is an important topic, that's why I'm touching over here, okay? It is not possible to understand directly this particular topic, okay? Rest of the other topics which I have shown you, those are easy, those you can understand, but this one is difficult, okay? But if you can, then you guys are intelligent, okay? Now see, we say voltage in case of resistance and current are in the same phase. Okay. Now, voltage in case of capacitor lags current by how much? By how much? We say pi by 2. It is behind current by pi by 2. Voltage in case of inductor leads current by pi by 2. Here it is leading. Lead means anti-clockwise, lag means clockwise. So we say this is called the phasor diagram of LCR circuit. This is the phasor diagram of LCR circuit. Now, if in LCR circuit, this VL becomes greater than VC, this factor is greater than this, can I not say resultant will be VL minus VC, this minus this, okay? And this will be VR, okay? Now, resultant of this one and this one will be from the center side, this will be V net. And if somebody asks what is the value of V net will be under root of this square plus this square. Now, if I say this factor is greater than this, then in that case, phasor net voltage is going to be, that is VC minus VL whole square plus VR square. Okay. Now, let's make the impedance diagram. Guys. We say previously it was over here VR, VL, VC. Right now we write over here R only. How do we write? We say instead of VR, we write current into R, V is equal to I into R. So this one, in case of VL, if we write VL will be I into XL. Like in case of resistor, you have got resistance. Similarly, in case of inductor, you have got inductance. Okay. And not inductance, this is called the inductive reactance. This is inductive reactance. This behaves like a resistance only. Like in case of resistor, you have resistance. In case of inductor, you have inductive reactance. So here you'll be writing its resistance, you'll be writing its XL, inductive reactance. This is capacitive reactance. Okay. This is called the impedance diagram, in which you show resistance vectors, in which you show resistors only, okay, in which you show resistors only. Now, my dear friends, and how do you write it? We say VL is equal to I into XL. How do you write it? V is equal to I into R. How do you write this? V is equal to I into XC. Now this I, you neglect, you write XL, R and this. So basically in impedance diagram, we show only resistances. This is resistor, resistance. Okay. Now, what I'm trying to say in this particular case, let's suppose I am saying, by any chance, XL becomes greater than XC. Inductive reactance becomes greater than capacitive reactance, then this will be the resultant factor. This is the resistance. This is called as Z. Their resistance, net resistance is Z, where Z is called the net resistance of XL minus XC and R, and it is called impedance. And this Z will be under root of this square plus this square, under root of XL minus XC whole square plus this. Even you can find the value of this phi also. Tan phi is perpendicular by base. Perpendicular is XL minus XC, base is R. Base is R. Base is R. Now, if XC becomes greater than XL, in that case, this will be the value of impedance. Okay, XC minus XL whole square plus R square. Okay, so this is called when LCR is capacitive in nature. If you say, sir, guys, come over here. When it comes to the inductor has got resistance XL. Capacitor has got resistance XC. Resistor has got resistance R. Okay. Now, if I say XL is greater than XC, then LCR is inductive in nature. If XC is greater than XL, then LCR is capacitive in nature. That is what is mentioned over here. If XC is greater than XL, then LCR is capacitive in nature. This will be the impedance. Okay, here also you can find the value of tan phi. That is perpendicular by base. XC minus XL divided by R. XC minus XL divided by R. Okay. One more important thing. Capacitive reactance, it is equal to 1 upon omega C. Even you can write it like this. XC is equal to 1 upon omega means 2 pi F into C. This inductive reactance is omega into L. This is 2 pi F into L. You can write it something like this. Okay. If somebody asks you to plot the graph between resistance versus frequency, there is no relation. Graph is a straight line. Sorry, graph is constant. In case of XL versus F, recently I told you XL is directly proportional to F, so graph will be straight line. Okay, when it comes to this, we say XC is equal to 1 upon omega C. We say XC is equal to 1 upon 2 pi F into C. XC and F is inversely proportional, so graph is rectangular hyperbola. Let's take a look at this. R, L and C. Okay. In this particular case, find the value of XL, XC, Z. First, value of XL, that is omega into L. Now, from this equation, I is equal to 10 sine of omega t. Omega in this case is given as 100. Okay. Omega in this case is given as 100. See, here in this case, you guys can directly write omega is given as 100. Okay. Omega is given as 100. If you want to find the value of XL, XL will be equal to omega into L. Omega is given as 100. L is given as 0.16. So that will be 16 ohms. So value of XL, inductive reactance, is 16 ohms. When it comes to the value of XC, XC is 1 divided by omega C. That is 1 upon 100 into capacitance of this is given as 500 microfarad. Okay, into 10 raised power minus 6. Okay, so once you solve it, it will come out to be directly. I will be writing over here that is 20 ohms. Now, guys, tell me in this particular case, when it comes to XC, when it comes to XL, which one is greater? We say XC is greater than XL. If XC is greater than XL, LCR is capacitive in nature. Okay, if XC is greater than XL, so could you please tell me what will be the resultant diagram, sir? Diagram will be something like this. This will be R, this will be XC minus XL. Okay, and this will be the resultant, that is Z. This is going to be phi. Now tell me, what is the value of impedance in this particular case? Under root of, this will be XC minus XL whole square plus R square. Z will come out to be under root of XC minus XL. 20 minus 16, that is 4 square plus 3 square, because resistance is given as 3. So Z will come out to be, that is 20 root 25, that is 5. So Z comes out to be equal to 5. Even you can find the value of tan phi. So tan phi is perpendicular by base. Perpendicular is XC minus XL, that is 20 minus 16 is 4. Base is R is 3. When is the value of tan as 4 by 3? When phi is 53 degrees. Tan theta is 4 by 3 when theta is 53 degrees. V naught. How do you find V naught? V naught is peak voltage. It is peak current multiplied by net resistance of LCR. Peak current. I is equal to, you can write it like this. I is equal to I naught sine of omega t. I naught is 10. Peak current is 10. So V naught comes out to be 10. Z is 5. That is going to be 50 volts. Okay, that is going to be 50 volts. Okay, cool. Now, this one. First V of t. This one is not mandatory, but still I can show you. I'll show you one rest of the equations you'll be creating from your end. Now see, guys, take a look. If I say in this particular case, what is the equation of current? Equation of current is given as 10 sine of omega t. 10 sine of omega t. Okay. 10 sine of 100 t. 10 sine of 100 t. This is the equation of current. Okay. Now, when it comes to the voltage, I have told you here in phasor diagram, voltage in case of resistance and current, both are in the same phase. So whatever is the equation of current, same will be for voltage because they are in phase. So I'll be writing over here voltage VR of t, voltage in case of resistance, it will be that is peak voltage in case of resistance. Okay. Then we say sine of 100 t. Equation will be same. Why? Because both are in phase. That's why. Now V naught, what is the value of V naught? Okay, V naught we calculate in case of resistance. That is I naught into R. Peak current divided by resistance. Then we say sine of 100 t. I naught is how much? 10. R is 3. That will be 30. 30 sine of 100 t. This is going to be VR of t. Okay. Even I can show you this net voltage also. See guys, in this particular case the phasor diagram looks something like this. This is V net, V of t. Okay, and this is given as phi. This is 53 degrees, and this is current is 10 sine of 100 t. Now guys, if you have to write the net voltage equation, tell me, don't you think that net voltage lags behind current by how much? By 53 degrees. So current is given, take reference as current. So we will be writing net voltage V of t will be V naught, peak voltage, then sine of 100 t. Now it is lagging current by how much? 53 degrees, minus you can say 53 degrees. In this case, we did not mention anything plus minus. Why? Because VR and current, they are in the same phase. That's why. Okay. Now here, this V naught we have already calculated. That is 50 volts. We'll be writing over here 50 sine of 100 t minus 53 degrees. 100 t minus 53 degrees. Is this clear? Is this clear? Is this clear? Now, similarly, what you guys can do is, you guys can find VL of t, VC of t. Okay. Now guys, when it comes to the VL of t, This is the real diagram, okay? Phasor diagram. This is VL, this is VC, this is VR, and this is VNet. Okay, so this is current. Now, guys, don't you think that in this particular case, guys, in this particular case, we say VL leads current by 90 degrees. Okay, VL leads current by 90 degrees. So we write VL of t, voltage in case of inductor with respect to time. It will be peak voltage in case of inductor, peak voltage in case of inductor. Then we say sine of 100t plus pi by 2. Plus pi by 2 means plus 90. Now, how do we find this? This is I naught into XL. Then we say sine of 100t plus pi by 2. Okay. Now, I naught, what is the value of I naught? That is 10. XL is how much? 16. So 10 into this will be 160. Sine of 100t plus pi by 2 or 90 degree, one and the same thing. This will be the equation of this. Okay. And so this I want you to calculate from your end. Okay, average power. For average power, you'll have to study another topic in detail, so ignore this. Okay, power factor is simply, okay, that is cos phi, that will be R divided by Z. Okay, base by hypotenuse, R by Z. This will be the power factor. Okay, so these are the details of LCR. These are the details of LCR. Now, one more important graph in LCR is over here. That is graph between impedance and frequency in case of LCR. Guys, see. This is the equation of impedance. Okay. Instead of XL, you can write omega into L minus 1 by omega into C square plus R square. Omega, you can write 2 pi F into L. Here also 1 by 2 pi F into C plus R square. Now, guys, let's suppose if you keep frequency as 0. Let's suppose frequency is 0. If frequency is 0, this term will become 0. This is 1 divided by 0. This becomes infinity. So means this term is infinity. So infinity plus something means infinity. In that case, impedance will come out to be infinity. So if you made the graph between Z versus F, if frequency is 0 means over here, Z is infinity. Z is very large. Now, second. If you keep frequency as infinity, if frequency is infinity, so this term will become infinity. This term will become 0. 1 by infinity is 0. Infinity plus something will be infinity. In that case, Z will be infinity. So if frequency is 0, Z is infinity. If frequency is infinity, okay, Z will be infinity. So that's why graph is something like this. This is graph between this and this. Now, this is the point. This is point. If XL becomes equal to XC, this term will become 0. Z will be equal to root of R square. Square and root will cancel. Z will come out to be equal to R. In that case, the resistance will be impedance, net resistance will be R. So when guys, when frequency is 0, impedance is infinity. When frequency is infinity, we say impedance will be infinity. And when XL is equal to XC, Z will be equals to R. This will be the graph. And this condition is called resonance condition. This condition is called resonance condition. Resonance condition in an LCR circuit means when XL becomes equal to XC. When XL becomes equal to XC. Okay. So when XL becomes equal to XC, this is called resonance condition. In this case, net impedance, net resistance of LCR will be equal to the R, resistance only. Okay. Now guys, if XL becomes equal to XC, here it is omega L, 1 by omega C. Take this omega here, omega square is equal to 1 by LC. So omega will be equals to 1 upon under root of LC. This is called resonance angular frequency. Even you can write it like this, omega is equal to 2 pi F. Instead of omega 2 pi F, so you can write F is equal to 1 upon 2 pi under root of LC. This is called resonant frequency. There is a question on this that is given over here. Okay, this I will give you as homework. Okay. 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 This I'm giving you as homework over here. Okay. So, my dear friends, that is all for today. Okay. See you guys in the next session. Till then, bye bye and take care. Okay. And once I end the live stream, make sure and guys, make sure you smash the like button, and after ending the live stream, do comment down below. Okay, do let me know how was the session. Okay. Take care and bye bye.